All right. So this is a lesson about factoring. We've done all this already this year if you're in Mr. Winkler's Algebra 2 class, but it's a huge part of Chapter 7. You have to be able to factor. So if you know how to factor, you're in pretty good shape going in. If you don't know how to factor, that's okay. We can revisit factoring. There's a whole bunch of different ways to factor. The first one you should always look for is a greatest common factor. So an example with greatest common factor, if I just have like 4x squared plus 12x, that can be factored. Sometimes I call them the box problem. So if you put 4x squared and 12x in a box, what goes on the outside? Well, I can take a 4x out of each of them, so 4x. And if I take a 4x out of 4x squared, I'm left with x plus 3. So this factors to be 4x times x plus 3. That's greatest common factor. Greatest just another example. If you have 8x cubed plus 2x minus 6, we'll go like this. You can take a 2x out of each of them, and it'd be 4x squared plus x minus 3. And then you could try to continue to factor. Actually, this one can continue to be factored. But for right now, greatest common factor, you're just taking it out of every term, which I did here. Some people would put this into a box and go like this. But this is what our answer would be. Another type of factoring, I just call them diamond problems. So these are trinomials. X squared plus 6x minus 16. We're looking for two numbers that multiply to be negative 16 and add to be 6. So 8 and negative 2. So it factors to be x plus 8x minus 2. This number goes on top of the diamond problem. That goes on the bottom. X plus 8 times x minus 2. There's going to be a lot of them, especially in section 7.3, just diamond problems. Just another example, if we have x squared minus x minus 72, negative 72 is on top, it would be negative 1 on the bottom. So it's x minus 9, x plus 8. Another type of factoring is difference of squares. Okay, so difference means subtracting, squares means you have perfect squares. So example, if I have x squared minus 9, what's being squared there? And what's being squared there? Well, x is being squared there. So I can put x in the first spot in each spot. 3 is being squared there. And then you just add 1, you subtract 1. You might have 4x squared minus 49. Well, that's a perfect squared. What do I have to square to get 4x squared? That'd be 2x. And 7 squared is 49. We add 1, we subtract 1. So that's difference of squares. There's a difference of cubes. And there's a sum of cubes, but we'll do difference of cubes. So the formula for that, a cubed minus b cubed equals a minus b, a squared plus ab minus b squared. So an example, if I have x cubed minus 8, well, the a here is going to be x, and the b here, well, what is cubing to get 8? Well, that'd be 2. So a is x, that's what's being cubed here, and b would be 2. So then you just plug in x and 2 into the formula for a and b. So it'd be a, which is x, minus b, which is 2, a squared plus a times b, so that's 2x, minus b squared, so minus 2 squared, so minus 4. Another example could be, there aren't that many examples, so I'll say 27x cubed minus 1. Okay, so recognize what a and b are. What do I cube to get 27x cubed? Well, the cube root of 27 is 3. Cube root of x cubed is just x, so it's 3x, and cube root of 1 is 1. All right, so using our formula, our a is 3x minus b, a squared plus a times b I'm looking at my formula up there, plus b squared, which is 1. This should be a plus. Sorry about that. So that's a plus, and that's a plus. All right, so that would be difference of cubes. Next one would be sum of cubes. It's really similar to difference of cubes, just a different formula. So if I have, here's our formula, a cubed plus b cubed. That would be a plus b times a squared minus ab plus b squared. That's the sum of cubes. So example, if I have x cubed plus 64, recognize what your a and your b are. So a is x, or b, well, the cube root of 64, 4 times 4 times 4 is 64, so b is 4. Then we just plug them in. So a is x, b is 4, a squared minus a times b, so 4x plus b squared, which is 16. Okay, so that's the sum of cubes. Moving on. So we have a trinomial where the leading coefficient is not 1. So how am I going to write that out? I'll just call it ax squared plus bx plus c. So if I have like 6x squared plus 7x minus 3, and I was going to factor that. It's like a modified diamond problem. We can call it that maybe. Modified diamond. So we do a diamond problem, but rather than putting -3 on top, we're going to do 6 times -3 because there's a number out front. Before there was nothing there, so a 1. So even if you had multiplied like the 1 times -3, it would still be -3. But since there's a number out front, we're still multiplying them. So I get -18 on top and 7 on the bottom. So 9 and -2. And then we change the 7x to be a 9x minus 2. That was the purpose, or 9x, 2x. That was the purpose of the diamond problem, to change the 7x into 9x and -2x. So now we're going to bring the 6x squared down and the -3, and we have to factor this by grouping, which is actually another way of factoring that I didn't even talk about. So I'll embed factoring by grouping within this type of a problem. So it's 2 different greatest common factor, 2 different box problem. So if I can take something out of here, it would be 3x, and I'd be left with 2x plus 3. And I could take a negative 1 out here, and it'd be 2x plus 3. If we do it right, these 2x plus 3 and 2x plus 3, those binomials should be the same, which they are. So then we just have 3x minus 1 left after you take a 2x plus 3 out of each term. Okay, so this trinomial factors to be 3x minus 1 times 2x plus 3. You could FOIL this and you'll get the original. It should work. Okay, so that was factoring by grouping and modified diamond problem where there's a leading coefficient that's not 1. Maybe I'll do another example. Let me make one up here off the screen. So I've got 12x squared plus 11x plus 2. So we're going to factor that. First thing we want to do is make a diamond problem. 12 times 2 is 24, and 11 goes on the bottom. It would be 8 and 3. So change the 11x to be 8x and 3x. I still have a 12x squared and a 2. Factoring by grouping, I could take 4x out here, left with 3x plus 2. I could take a 1 out, and I'm left with 3x plus 2. So it factors to be 4x plus 1 times 3x plus 2. You won't see a lot of these in 7.3. Most of what is in 7.3 is greatest common factor and just regular diamond problems. Maybe a little bit of difference of squares. Okay, 2 more that I'm going to talk about. Quadratic type. You won't see a lot of these right away in Chapter 7 either. Quadratic type is where we have like it resembles a quadratic expression, but it isn't quite a quadratic expression. So if you had like x to the 4th minus 2x squared minus 15. Okay, so that's not a quadratic because it's a 4th degree polynomial. But it can resemble one if you just say, well, a is x squared. So if a is x squared, then I'm going to replace that x squared with a. By the way, whatever your a is, it's usually going to be whatever it is right there, if it's a quadratic type. So this is x squared times x squared, or x to the 4th. So that is actually a squared. So it becomes kind of like a quadratic polynomial. Okay, so that factors diamond problem. X minus 5x plus 3, or a plus 3, sorry. And then we said a is x squared, so you just replace your a with x squared. And we're done because neither of these can really be factored. It's not a difference of squares. Technically, if you called 5 a perfect square, but we won't have that. We won't have square roots that we're going to be dealing with perfect squares, so we would be completely factored for that one. Which brings me to completely factoring. Sometimes there's going to be multiple stages to it. So the first thing you always want to do when you factor is take out a greatest common factor. So this is completely factoring. Looks like I'm going to have to move quickly. I have like 30 seconds left before the video stops. So if you have like x cubed plus 2x squared minus 32x. Well, I can take out a greatest common factor right away. I can take out an x out. And then this factors to be x plus 8. No, it doesn't. And I was going to do 4, but that didn't work. I cracked under pressure.